Good afternoon, everybody. It's a pleasure to be here today with you and to receive Jason as our presenter today. Jason's bringing a very, very nice topic today, which is RAG. I personally am very, very interested to hear him talking about it. This is a topic that we have in our course, indeed, right, Jason?
Yes, that's right. It's one of the last modules.
Yes. So yeah, it's gonna be very, very fun to see what Jason can bring to us. So Jason will present himself and will turn off his camera, right, to present Jason. So welcome.
Indeed. Thanks, Felipe. Yes, unfortunately, a few technical issues here. I've ended up on a machine with no webcam on it. So I'm just on my phone at the moment, just so you can see I am a physical person, I exist. But I'll hand over to my laptop if that's all right. And I'll just run through the demonstration if that's okay with you. Okay. Right. So just switch over. Right. Okay. Felipe, can you hear me okay?
Yes, I can hear you perfectly.
Perfect. Okay. Right, in which case we'll get started. So I'm just going to share my screen and we should hopefully be able to see what we're looking at. And we'll get go. Okay, if you can give me access to share, that would be great.
You have it now.
Perfect, thank you very much. Right, okay. What I'm just going to do is just share a portion of my screen over here. There we are, great. We'll run through everything. So I've got a couple of demonstrations as well here to go through. Right, okay, perfect. Hopefully we can see that all okay, yeah?
Yes, that's right.
Brilliant. Okay, so what I want to talk today really is about how we can keep some of your data secure. What are the options around that? So an obvious one that a lot of people talk about is RAG. So I hear a lot of things about RAG, some of it correct and some of it incorrect. And I think a lot of people think it's a golden bullet. It is very, very useful, but I thought it might be a useful thing to put together a short demonstration so that people can understand the pros and cons and where it might fit into your workflow. Okay, let's get started. So first of all, then we'll really be kind of pivoting this around the whole idea of really using AI and actually then working with confidential data and real estate modeling. So really what I'll be talking about is the strengths, the weaknesses, and what to watch out for. Okay, so where can AI help? Well, financial modeling in real estate involves huge amounts of data and spreadsheets, often also reports, contracts, rent rolls, obviously, market comparable data, leases, valuations, due diligence documents, etc., etc. So I'm assuming that most of us by now are probably used with one of the classic online models, such as ChatGPT being an obvious one, or even something like Claude. These are obviously great. We can feed in certain amount of data, but there are a couple of trade-offs as this in terms of, first of all, dealing with large amounts of data, so uploading files, etc., but more around the security of this. The reason where this really comes from is we need to bear in mind that these large language models are public. So if they're public, once that data gets fed into a large language model, it's there available for everyone. Now, of course, in many contexts, this is perfectly fine and not a problem. In fact, in many cases, this is a good thing. But of course, if you're dealing with potentially sensitive information, how do we get around that? Because that's not an ideal situation. And that's really where we'll be coming from today. So AI then, especially a large language model, or LLMs as they're called, and we'll call them an LLM for the rest of this talk, can help tasks like, for example, summarizing data extracts. So we can say, for example, upload data in a CSV or similar kind of format, and we could ask it a question like, for example, the example I've got here is what's the escalation clause in the lease? We can use it for question answering, and example, we can set up scenarios as well and ask it to comment on those. We can also use it for automating drafting, standard memos, investment summaries, that kind of thing. So again, we can feed it in conversations or large amount of data, ask it to summarize it, put it into things like draft letters, LOUs, contracts, that kind of thing. We know that then, hopefully, that this is exactly the sort of thing where AI really stands out and can be a very, very useful assistant. But to do this safely with confidential data, so in other words, let's say, for example, your firm's leases, valuations, tenants, etc., we've got to be very careful about that because we can't have, say, for example, people's names and addresses or even sensitive information ending up in a large language model. And that's really where we're looking at this today. So the core question is how can we combine AI's power, so the good side of what it can do in terms of the data processing, but without leaking or exposing sensitive data. Okay, so there are three approaches I'm going to look at today. The first one then is probably what we've already done. So we could use something like OpenAI, so ChatGPT if you like. We've obviously got Claude by Anthropic, and there are others as well. So Grok being a good example. Now we can upload a prompt, we can upload some data. That would typically be in a non-proprietary format, so something like a CSV or something like this, basically a text format if you like, as opposed to proprietary being something like Microsoft Excel, which is a binary format. Although some of the AI models are now even learning to work with that. But either way, what we're doing is we're uploading this data and we're uploading a prompt. And really what we're doing is we're just asking the question and letting the standard kind of ChatGPT or whichever tool we're using process that data and come back with an answer. In many cases, this is perfectly fine. We can just do this with a regular account. We don't need any specific infrastructure, and that we can pretty much start straight away. Next, we could maybe use something like a hybrid approach. So we'll look at that shortly. So this is where we're using something like retrieval augmented generation. So I'll go on to explain what that is in a second. The basic idea is we're now starting to use the API for some of these tools. An API then is an application programming interface. Of course, when we go to something like ChatGPT, we go to a website, we log in, we type our prompts, and we can visually see the answer coming back. But the reality is, the software industry and websites and anything to do with being online is all run via APIs. This effectively means that we can push and pull data around the internet across software platforms without actually having to use a user interface. So for example, if any of you have got a smartphone, every time we log on to pretty much any app we use, could be Facebook, a social media platform or anything like that, all the data that ends up on that application is going to be pulled via a database through an API. That API will link up to, for example, Facebook or X and pull down all your latest posts, etc. APIs are used across the internet for getting anything from exchange rates to getting property information. So Zoopla, Rightmove, they all have APIs. The main thing is some APIs then are exclusive to that package. Some of them are paid, some of them are free. So the AI tools are absolutely no different. They also have APIs. So if I want to leverage any of the functionality on, for example, Claude or ChatGPT, I can call out their API and do exactly the same queries, but without having to use the user interface. Now, it's fair to say we're seeing this a lot at the moment. Our favorite software platform now has an AI feature which generates a prompt for you or generates some report or some data for you. How are they working behind the scenes? Well, that's a good question. I can't comment on the individual software package, but generally speaking, they're either going to be hooked up with an existing API like ChatGPT, etc., and just sending through some data, summarizing it and getting it back. So pretty much exactly what we'll look at shortly. Or in some cases, they might be also looking at what we'll look at later, which is where they might be hosting their own large language models so that they can keep the data secure. Either way, APIs then are very much the backbone of the internet and data processing. So the hybrid approach then works on the basis that we're going to use retrieval augmented generation. So in other words, we're going to augment an AI query using our own data. But we will be using a library like, for example, ChatGPT, but we'll be using it through the API. The last one then is we could look at that and say, well, the medium approach is all right, but we've still got to have a public LLM in the mix. Now, just before, it's important to note that ChatGPT, for example, say, well, if you're using our API or if you're using retrieval augmented generation, none of that data that is sent and augmented actually then gets included in a large language model. The point that I'll make later is that is true, and I've checked their terms and conditions, and that is very much what they claim. However, that's not to say that it could be true. We don't really know that. We can't really guarantee that. And not only that, that could change. I mean, without getting political, there's some pretty big shifting changes going on in the world. We've recently seen 10% share, for example, in Intel being handed over to the American government. So whatever your political views are, you may take the view of actually, I'll take that with a pinch of salt. We don't know if that's necessarily true. So if you're in a situation where we have to use AI over very sensitive data and we don't want to take the risk of trusting whichever platform, our last option then is we could say, well, okay, we'll host our own large language model. So I'll show you a tool that allows us to do exactly that. We can take a large language model, we can pull it down, put it on our own infrastructure, train it if we need to, but the easiest way is to use something like retrieval augmented generation with our own large language model. At this point, we're not relying on any of the public LLMs whatsoever. So say, for example, if you were going to build a platform that effectively needed to have ultra secure ring fenced AI processing, this would be more likely the sort of route you want to go. However, there are trade-offs with that, and I'll show you that later. Okay, so what then is RAG? Well, I wanted to talk about RAG because it's one of those terms that's sort of banded around and maybe in some cases seen as a bit of a golden bullet. It is certainly a useful thing to do and it is very, very popular, but there are some trade-offs. So I guess the best definition I found is RAG is a technique where before asking an AI model to answer a question, you retrieve from your own documents relevant pieces of text, so context as we call it, and we feed those along with the user's question into the model. This ensures the model's answer is more grounded in your proprietary data and avoids having to ingest all that data into the model itself. So in other words, think of a large language model, ChatGPT if you will, as being a big, very well trained brain on the internet, and we can just augment that by feeding in some of our own knowledge into that, okay? Let's walk through the process. So a good graphic here and a good resource, this comes from promptengineering.org, and this is actually a really, really good, useful resource for if you want to learn anything further about this. To try and put this in context then, is the user basically initiates a session. What we do is we convert everything into what's called an embedding. Now, embeddings are the key. Think of those as rather than like a two-dimensional data set, perhaps something like a spreadsheet, you could argue would be sort of in that realm. This is three-dimensional data. So this is then stored in a vectorized database. The basic process works like this. We'd have whatever content that we need. That could be documents, it could be pretty much anything. We can then get that converted into embeddings, which are stored then into a vectorized database. So typically we'd have some sort of a process that would do that first. So let's imagine what we're doing is we're building up our localized database full of knowledge. Now that could be documents, it could be data that we're working with. The example that I'll show you shortly is we've actually crawled a website, we've taken all the content from that website, say a knowledge base, for example, we've then converted that into embeddings, which is then stored in our local database. So this is the augmented part of that process. So imagine then we've got our local database. So anytime that we ask a query, we want to then also feed elements of that database into the query as well. This is then when the contact search comes in. So you'll see over here, we've got the embedding and vector database. The vector databases actually are quite small. They're quite easy to store those things locally. It's amazing how much data you can get into a very small amount of highly optimized vectorized database. And don't worry, I'll show you in a second exactly what a vector record looks like. So we've asked the question, we've got our local database here, which we've just trained using a simple kind of importing model. These are quite easy to use. There are lots of those around. The first thing is obviously you find with any AI engine underneath the hood is when we ask it a question, that itself then needs to be converted into embeddings. So once that is converted into an embedding, at that point, we can take our data, our optimized query, send that through to the API. It will then take our data, augment it with the context that we've sent over, and then send us back a result. And that's really how the retrieval augmented process works. So again, we're augmenting it with our own data. That's the main key here. Okay, let's break that down into a few steps. First of all, then is the indexing side of things. So we can take our confidential data, leases, reports, etc., break them into manageable chunks. So these then would then be converted into the embeddings, which is a numerical vector representation. This really is what AI works on underneath the hood. We can then store those in our database. Okay. This is a very simplified version of what, for example, embeddings might look like. In here, you can see I've got a couple of very simple words, cat, dog, apple, strawberry, for example, and you'll see really it's just a large range of numbers, and those numbers then are stored in a 3D format. So some of these are all arrays, but you might often have an array within the array. So again, it gives you a 3D version of that data that then shows the proximity of the letters to each other in the context. So there are lots of then local AI models. In fact, even ChatGPT is a common way to do this, whereby we can use its embedding engine, whereby we feed some text and say, give me the embeddings for this. Now, of course, depending on how secure you want your data, it could be perceivable that we could just use a local model to do all that for us. It's a relatively lightweight task in the grand scheme of how these work. Okay, so in steps then is we ask a user, so what's the rent escalation clause for tenant A? That then gets converted into embeddings. and then we can then feed that in to one of the APIs and ask it to give us a response. So the real thing then is, with these APIs, are we going to be using something like ChatGPT, for example, or are we going to be using this locally? So OpenAI claims that if we're using this method, it won't be taking any of our data, it won't be used as training data, and won't end up in a large language model. So truthfully, most software vendors will use this because it's actually the easiest and cheapest way to do it. You don't have to then invest in the infrastructure to run all of the kind of models yourself. Okay, so once you've done that, is we will then going to construct the prompt. So you might retrieve the prompts. There might be 2 or 4 depending on the size. We'd then build up the prompt. That would include the user's question. And then obviously any retrieve context pieces. For example, we then might give it the relevant results, examples, etc. And quite often might have some instructions. We tend to see that a lot with these engines, whereby we've told it what we want, what the outcomes we are. We then telling it what data we're going to pass up. Sometimes we can even tell it what parts of the data we want it to use. And often we then might have modifiers at the end of that prompt. Here's a good example where we might say, base your answer only on the provided context, don't hallucinate. We see this quite a lot, where sometimes we might put conditions in where we explicitly don't want it to make certain decisions, tell it how we want to answer, the sort of format that we want. If we want to have, say, for example, a combination of some data coming out with a response, we can be very, very explicit with AI tools and put all those conditions in. If we get the chance, I'll show you exactly that example later. Okay, final part then is the LLM generation. So this then combines the prompt that's sent over to the large language model and then generates the answer. So this is all then going to be based on a combination of everything that the large language model already knows, plus your augmented data. Some people quite often might also use, I see this a lot, where you might use another LLM, for example, just to check the output that you've got. Sometimes I see this where people need ultimate accuracy. I've very often seen people, say, for example, use RAG or a similar thing, and then use a different LLM, for example, ChatGPT or Claude, just to double check the actual response that it got back. Sometimes people just spot check small examples just to check it. But again, it's quite a common cause to use AI tools or different AI tools to check your responses. We worked on a business valuation calculator recently, and that was exactly what we did to check all the answers and come back. But it was once we managed to refine the prompt and get the model working, it actually served a very good purpose and worked very, very well. Okay, so why this helps with confidentiality and control. So we don't need to load an entire database into the model. We can only then just upload the parts that we need. We can also control the chunks. Again, they're going to be controlled by filters. We can add access rules into this. We can make updates that don't require the model, and we can enforce sanitation. Okay, so can it work with ChatGPT? And I'll say ChatGPT because it's fair to say that it's probably one of the most common AI engines. So really, the point is it secure? Yes. So we can build a RAG style pipeline that uses OpenAI, ChatGPT, or we can also do this with similar LLMs. So what we can then do is we can host our own vector database. Again, they're quite small, so there's not a great deal of overhead with that. And then we can send over our prompt to ChatGPT. That will work just fine. Okay. What about then security and privacy? So here's a couple of things that we need to think about. So data leakage. So even when the chunks you send might contain sensitive data, you might need to redact sensitive identifiers. So if it is going to ChatGPT, I would probably recommend, if you've got something that's you need to take a slight risk or got something that could potentially be, quite often I see a lot of people will anonymize data. That's quite a common thing. Because when you boil it down, if you take the context away for, say, for example, a financial document, once you take addresses out and personally identifiable information, sometimes actually what's left out of context makes no odds whatsoever. So that could be a possible way to do that if you wanted the easy approach of using something like that. That's actually very common, and I see a lot of clients do exactly that. They'll anonymize data first to basically mitigate the fact that there might be data linkage. Ultimately, as I mentioned earlier, do you trust the provider? So ChatGPT, for example, at the moment says if you're using our API, none of the data that you send through and none of the data sent via RAG, via vectorized data, will also be included in their LLM. Again, do you trust them or not? That's not my decision, but it's definitely something that you should take a view on. When I last looked, it's definitely something they're claiming that that data is not used within the API. There has been leakage in the past. So when I'm talking about leakage, although an LLM might not store your entire document, in rare cases, it might memorize or leak parts of the document history. There have been known cases of this. Lastly, then, is the regulatory side of things, the compliance constraints. So, for example, for highly regulated example personal data with regulated financial documents, sending even parts of the third party might actually breach those rules. Again, you'll know that knowing by the compliance that you're working with. Okay, so what about then running a large language model locally? I want to introduce you to one called Ollama. This is probably one of the most common ones. So Ollama then is a large language model, which is a set of framework that we can actually then use to download and run our own LLMs locally. I just want to show you that if I just take you over to the website, if I just store this here. Okay. So we obviously had DeepSeek come out not that long ago, and there was a lot of controversy about that in terms of, oh, it's built by the Chinese, they could be stealing your data, etc., etc. Now, whether that's true or not is difficult to know, but I thought, well, okay, look, they've actually open sourced it. So it's available on Ollama. So whether it's been there or there's political controversy around it or not, I'm going to take the view of, I'm actually just going to download it and run it locally. So if we actually have a look at Ollama, you'll see that we've actually got many, many models here. Now, it's fair to say, when I first started using Ollama a couple of years ago, there were about 6 or 7 different models. Well, as we know at the moment, AI is a very popular subject. So you'll notice that there are many, many, many more. In fact, I'm not even going to scroll through them all here. There are a lot of different models there. Now, as we probably noticed, we're starting to see AI be optimized for image generation, video generation, even cloning voices, various other different things. So you'll find a lot of these models are really adapted for different things. We've got vision models, we've got thinking models, embeddings, which we talked about earlier. Embedding models you'll find are very highly optimized and very small. They don't take up an awful lot of room at all. So DeepSeek, of course, which was quite controversial recently, we'll see that this is available. We can install Ollama, we can download it, and we can run it on any machine. Now, one thing is when you start looking at models in this context, they're all different sizes. You'll notice that we've got this, for example, 1.5B, 7B, 8B, 14B. What is the B? Well, simply put, B is billion. That's how many different parameters it's been trained on. So it's fair to say something like 70B has been trained on 70 billion different parameters. Now, all those parameters in the end take up space. So some of the larger models, you'll find that they actually take up several gigabytes, in some cases even terabytes. They're not small at all. They can be quite big. That said, truthfully, with quite a lot of these models, you find that you don't actually need anything like the biggest models. Even some, quite often for many use cases, a very small model would be probably all you need. So that's the Ollama. This is an example of how we could run a large language model locally. So if we were looking to ultra secure things, although we could run it on a simple laptop, that would basically be the idea behind it. So if I open up a command prompt, then simply just to run that, we can have a quick look here. Just run up Ollama. Okay, get back to, there we go. Right, so for example, if I look at Ollama list, then we can see all the different large language models we've got here. These are ones that I've got up and running at the moment. Okay, and then if I just ask it to serve, hopefully it should serve up the last language model. Okay, looks like that's already running. Okay, cool. So I want to show you a quick example then. So I've got a tool here called Postman. Now, Postman is a tool that developers use, if you like, so it allows us to actually then create HTTP requests. This would be exactly the sort of thing that we would then use if we wanted to send off API requests. Now, I've got 2 examples here. Now, I've got one example, which is this one here. And what I've actually got is I've got Ollama running locally. It's running a relatively small data set, large language model running locally, and it's also running retrieval augmented generation. Now, what I've got is I've got a crawler process, and what that's done is that's gone through a website, pulled off all the content on that website, plus I've also fed in some PDF documents of specific instructions. So it's got information that I'm quite happy answered within this query, but The main thing is it's got information I don't necessarily want to be on public. Things like direct telephone numbers for the team, that kind of thing, opening hours and kind of special instructions in terms of what to do if certain situations occur. Not the sort of thing I'd want on a website, but I might want it as part of this prompt. To give you some context, what this feature is actually going to be an AI prompt that sits on a website. That means that you can ask it any question. It will then answer that based on what's on the website, the content on the website. Now, I want to give you a bit of context. That's one prompt that we've got working there. And if I have a look at another one, we should see, it's a bit bigger. So I probably just need a bit more space here. There we go. Right, there we go. Sorry, bear with me. Okay. For context, this is the same prompt, but this is running the same engine using OpenAI, and this is actually deployed. So this is sitting on the cloud. So to give you a bit of context, this is kind of like the second solution. So we're using OpenAI as our LLM. We're using OpenAI to do all our embeddings, and we've got a vectorized database, which is effectively storing all the content of the website. So the crawling process is already run. And what I can do is I can send it a command. So say, for example, here, I'm going to ask it a question, just like I would with any AI tool, and I want to get a response back. I'm just going to run that now, and we'll see what happens. Okay, so that come back with about 4.2 seconds. It's fair to say if I ask a similar question, it's probably going to be slightly faster than that. Where it's deployed, it might be spinning that up. Okay, similar, so 2.5 seconds. So I've asked it, how do I take payments online? And we can see that it's come back with a response. Now, instantly, I can recognize within that response that what it's done is it's answered that based on content on our website. Now, if I look down there, I can actually see that it's actually told me where on the website it's found that information. So this has been used via the embedding process. So these are the actual pages which it's actually based that answer on. Now, of course, this is website data, but truthfully, you could do this with a document, anything. I've even seen people write crawlers that will literally go through a file system, work out what type of document it is, for example, whether it's a PowerPoint presentation, Word doc, or Excel, and just scoop all the data in that way. And then have an AI tool that you can ask similar queries to. And again, it will then use that to process and answer questions that it's finding within the file system. So it's fair to say this approach is not quite as fast as, for example, going into ChatGPT and ask it a question, but I'd say it's probably workable. Now, by converse, if we then have a quick look here, this is going to be running, again, the same question, but this is all running locally. To give you some context, this is running Ollama. This is running a similar model. It's not going to be obviously ChatGPT's, but it's running a fairly heavyweight model locally. All the embedding process is done locally as well. Now, for context, this is running on a brand new Apple MacBook Pro. It's an M4, and it's about 3 months old. So it's fair to say it's not old hardware. I'm just going to ask the same question, and we'll see how long it takes. Could be here a while. Hope everyone's having a nice week. Very sunny here in London. Anyone up to anything nice this weekend? Anyone watch the football last night? There you go. 22 seconds. So exactly the same question, exactly the same process, but the difference is what I'm using here is rather than a large language model hosted in the cloud, it's running on this local machine. The quality, I would say, is just as good. It works in exactly the same way, and we've got the similar data. It's then citing the same articles. So the deal is then the trade-off is, yes, we've got ultra security here because everything is ring fenced. It's all literally running on a MacBook Pro. Now, in terms of the business, there's nothing to stop us, say, for example, creating your own hosting infrastructure. We could use Amazon AWS, even have a server in the office, however you want to do it. Any machine will run this kind of process. But as we can see, performance is a big trade-off. Now, one thing that we take for granted is when we go into, for example, ChatGPT and ask it a question, what we don't realize is just the vast amount of computing power it takes to get you that response that quickly. And it's not until then you actually put that on a local machine, you realize just exactly how much computing power you've got. So, for example, you could say, all right, but I could spin up a server. We could put this on Azure as infrastructure, run it on Microsoft, Amazon, Google, pick a data center. So, for example, I did a quick calculation a couple of weeks ago, and I thought, right, if we were to host something like this in the cloud, if we were to run, for example, our own large language models, medium size, have a process like this working, in terms of the kind of processing power that we'd need to get in order to get our query responses getting somewhere near the likes of, for example, ChatGPT, I think the cost was starting to be end up between £2,000 and £3,000 a month. Now, when you offset that against something like ChatGPT, where of course you could be doing all of this for sort of $20 a month, that's quite a big difference. So that's kind of the trade-off when we're looking at that. Okay, so that's Ollama as an example. There are others, but I thought there was a good way to maybe sort of demonstrate how that actually might work. Okay, so that's all well and good. Where do we go next? So you will find that there are people that have services that will do this kind of thing for you. I've put a few examples here in the notes. So RagArch is a good example. Langflow is a very good one, quite visual. We can do an awful lot with that. That tends to be what I'd say if you like people who are not necessarily programmers tend to use that. It's a little bit more drag and drop. But the main thing is, of course, you're using someone else's infrastructure and they're putting it all together for you. UltraRag's another good one, which I've heard of people say good things about. I put together a quick kind of comparison down here so you can see some of the differences between the two. Okay, so final thoughts just to wrap up. Hopefully we've got a better idea of how RAG works and what our trade-offs are. So RAG gives you then a way around AI models. We can use RAG with ChatGPT, OpenAI, Claude. All of those will support this kind of methodology. So for high confidentiality, running local models is a good solution, but obviously performance and cost are going to be your trade-offs there. And I would say probably with all of these things, start small, do a small pilot, test it, refine it, and get that working. With the example I've used here where we're using a website's data, it's fair to say there are others, there's Chatbase that does exactly that. It does all the index and everything for you. But that's not the point. Just wanted to build it myself. Okay, hopefully then that should cover everything. I hope you found that useful. And any questions?
Thank you so much, Jason. Let's see if anybody has a question. If you have, guys, please raise your hand so that we know that you have a question and write it in the Q&A box, please.
Felipe, shall I switch over? Would that be okay with you? Then people can see my ugly mug.
Yeah, you can do it. Right. Well, since there is no hand up, I think it's time to say goodbye. But before that, thank you again, Jason, for your wonderful explanation of what RAG are. As I mentioned in the beginning of this webinar, this is one of the contents that you, Jason, you present in our course AI application for real estate. So if anybody is interested in knowing more about this course, you are invited to have a chat with me, and it will be a pleasure. If you by any chance have any question, you attendee have any question, you can contact us too, and we'll be glad to answer you in detail. Okay, so thanks, Jason, once more, and see you next time.
No worries. See you again.